This video is for the curious, not experienced coders or anyone who's dabbled in coding before. It's a starting point for understanding what makes the tech side tick. From your phone to your washing machine, everything runs on the same fundamental logic. Let's break it down into segments where we go through the basics. We'll break this down into parts. First, the theory, what's actually happening under the hood. Then the logic, how coders structure their thinking. And finally, a practical example to tie this all together. Every time you make a sandwich, you follow steps. Get bread, add filling, close it, done. You don't think about it, but that's a sequence, a set of instructions you repeat the same way every time. That sequence has a name, an algorithm. Strip away the jargon, and that's all it is. A recipe. A set of clear, repeatable steps that take you from start to finish. Now here's the thing. Computers are incredibly fast, but they're also incredibly stupid. They can't improvise. They can't figure it out. They need every single step spelled out, in order, with no ambiguity. And this is how coders think. They break problems into tiny logical pieces. They don't just say, sort this list. They think about how to sort it. Compare two items. Swap them if they're in the wrong order. Repeat until everything's in place. That's the shift. When you start thinking like a coder, you stop thinking in outcomes and start thinking in processes. What's step one? What comes next? What do I do if something goes wrong? Every app on your phone, every website you visit, every time your GPS recalculates a route, it's algorithms. Millions of them, running in sequence, making decisions faster than you can blink. The skill isn't memorizing code, it's learning to think in steps. Computers seem smart, but they only understand a handful of things. Seriously, just a few types of information. Once you know what those are, you understand what every program is actually made of. And the first part is numbers. Whole numbers like 1, 42, or 10,000. Decimals like 3.14. Computers love numbers. They're built for them. The second part is text. Words, sentences, your name, and address. Programmers call these strings because they're just a string of characters lined up in a row. But you can think of it as anything you'd type. The third part is yes or no, true or false, on or off. Is a door locked? Is the user logged in? Computers constantly ask these binary questions. It's either one or the other, never maybe. The true or false part is called booleans in coding lingo. That's it. Numbers, text, yes or no. Every app, every website, every program you've ever used, built from just these three ingredients combined in different ways. Here's the key. When you write the program, you store these pieces of information in containers. You give each container a name, and the computer remembers it for later. Want to store someone's age? That's the container holding a number. Their name, the container holding text. Think of it like labeled boxes. One box says age and holds 54. Another says name and holds Eric. The computer doesn't care what's inside. It just remembers which box is which and grabs the right one when you ask. That's the foundation. Everything else is just telling the computer what to do with those boxes. So now the computer has information. Numbers, text, true or false. But information just sitting there doesn't do anything. The computer needs to make decisions based on it. This is where conditions come in. A condition is just a question with a yes or no answer. Is the number greater than 10? Is the password correct? Is the user old enough? If the answer is yes, do one thing. If no, do something else. That's it. Every decision a computer makes follows this pattern. If this, then that. Think about an ATM. You put in your card, you enter your PIN. The machine asks, does this PIN match the one on file? If yes, show the menu. If no, show an error. Simple question, two possible paths. Now here is where it gets powerful. You can chain these decisions together. if the PIN is correct, and the account has money, and the amount requested is available, then dispense cash. Otherwise, stop and explain why. Every app you use is full of these invisible checkpoints. When you log into your email, the system checks, is this the right password? When you buy something online, it checks, is the card valid? Is there stock? Is the address real? Coders call this if-then logic, but really it's just decision trees. One question leads to the next, branching out depending on the answers. The computer doesn't think, it just follows the branches you've built for it. Here's a question. What if you need to do the same thing 100 times, 1,000, 1,000,000? You could write the same instruction over and over, but that's tedious, error-prone, and quite frankly, insane. This is where computers really shine. They never get bored, and they never make mistakes from fatigue. The solution is a loop. A loop says, do this thing, then check if we're done. If not, do it again. Keep going until the condition is met. Think about it as a playlist. The computer doesn't need a separate instruction for each song. It just says, play the next track. Is the playlist over? No. Play the next track. Repeat. Or imagine sending a newsletter to 10,000 subscribers. You don't write 10,000 send commands. You write one which says, for each subscriber, send the email. The computer handles the repetition. There are really just two types of loops. The first says, do this a specific number of times. 10 times, 100 times, however many items are in the list. The second says, keep going until something changes. Keep asking for a password until the user gets it right. Keep scrolling until you hit the bottom of the page. That's automation in a nutshell. Find the repetitive task, wrap it in a loop, and let the machine do what machines do best. The same thing, perfectly, over and over again. One instruction, infinite executions. Let's put it all together. You tap Buy Now on an online store. What actually happens? First, the system collects the data, your name, that's text, your card number, also text, the price, a number, your address, the quantity, whether you want gift wrapping, all stored in those labeled boxes we talked about. Then comes the decisions. Is the card valid? If no, show an error. If yes, continue. Is the item in stock? If no, say sold out. If yes, keep going. Is the shopping address real? Same pattern. One question after another, branching based on the answers. Then the loops kick in. For each item in your cart, calculate the subtotal. For each discount code, apply it. For each step in the checkout, validate it. The same instruction repeated for every item in the list. And at the end, all those pieces combine into one result. Order confirmed or order failed. That's it. That's what's running behind every button you click. Data goes in, decisions get made, repetition handles the value, output comes out. Numbers, text, true or false, if this then that, repeat until done. You now understand the 3 building blocks that power every piece of software on the planet. The rest is just details. Useful details, but details nonetheless. The way coders think isn't magic. It's just breaking big problems into small steps and letting the machine do the boring parts. I hope this video was informative and maybe even made you curious about learning how to code. If you liked this video, please click the like and subscribe button.